Over 15 years ago, I started researching whether it is possible to define a point or a vector by using only a single number. After finding the most elegant solutions, I started seeing interesting patterns in the systems that I came up with. Notice how each of these frames represents a maze. No matter where you start, there is always a path to the center. On the other hand, there is always a path outwards into infinity. The black and white cells are defined similar to the way even and odd numbers are. Let's call the different variations of mazes you see on images levels. The longer the straight corridors, the higher the level of maze. Moving on to 3D, I wanted to achieve the same. I quickly noticed that in 3D, 3 different colors will have to be used, unlike 2 colors used in a 2-dimensional maze. Soon enough, I found a similar maze in 3D. Although its even more interesting 3D structures corresponded to the ones in the 2D maze, I'm talking in plural because I'm regarding to all the levels. There was a percentage of isolated cells in that maze. It wasn't until the beginning of this year, which is 2021, if you're watching this after the new year, when I finally uncovered the system to build 3D mazes that I was looking for. As in 2D mazes, the same rule applies to these mazes. Anywhere you start, by following the same color you can reach the center, as well as it can bring you into infinity away from the center. In other words, every cell is connected to the center. If we say the central point isn't connected to any neighboring cells, there are 6 isolated mazes in a 2D structure, in a 2D maze. Those are 3 white and 3 black. And 8 isolated mazes in a 3D structure. 2 blue, 3 green and 3 yellow. This rule applies to all the levels. Some other rules that can be defined in a 3D maze of any level. There's never more than 5 cells of the same color around a given cell, and each cell touches at least one cell of another color. In the same time, touches at least one of the other color of the 3 possible colors. This means that at any point the maze, if you want, one of those isolated ones I was talking about, is connected to other to other mazes which are of different colors. Regardless of the size of a maze, assuming it's growing from the central point in the same fashion as in animations, there is always one, but only one, completely straight way through: the structure of blue cells. This video represents the level 2 maze. Now let's watch this video only as a proof of concept. This video shows only the dead ends of the maze, of which the level is around 7. I'm not sure. This means that the dead ends could be bound to each other for providing stability when building 3D printing models, which are shown in the videos coming after the next picture. In a 2D maze, something like this can be done. Similarly, in a 3D maze, also something like this can be done. There is no complicated maths in the algorithms used to build these models. I think this is a breakthrough discovery in mathematics and geometry. I've personally developed the software used for creating all the images and animations seen in this video. I'm raising money to fund the creation of a scientific institute of some kind which will be involved in further research in this field as well as in several other fields which are not connected to this particular project. I aim to find like-minded people who will be ready to help out and work towards completion of my projects, most of which have already been started.